the final part of Isro-Vssc Technical Assistant Electronics and Communication Engineering previous year question paper with detailed solution. The exam held in 2015. Advertisement number 284 and post number 1243. Up to question number 40 we discussed in the part 1 and 2 videos. So consider question number 41. A FET has answer option A very high input resistance. Field effect transistor FET is a device that relies on the electric field to control the shape of the channel, therefore on the conduction of the channel, hence referred to as field effect transistor. FET is a unipolar transistor that involves only one type of charge carrier in its operation. Example, in JFET, the current flowing through the channel between drain and source is controlled by the voltage applied to the gate terminals, which is reverse biased. Additional note, in FET, the high output impedance was provided by the reverse bias of gate and channel, but there was some minority current. This drawback of FET was corrected using MOSFET, where an insulating dioxide layer was inserted between the gate and substrate to increase the channel impedance. Question number 42. How many cascaded stages of CE amplifiers will result in polarity inversion of the input signal? Answer is option B, 3. For any CE amplifier, voltage gain is minus GMRL, where GM is the transconductance and the equation is IC by VT, where IC is the collector current and VT is the thermal voltage, which is 26 millivolt in room temperature. Since AV equal to minus GMRL, the negative sign indicates one CE amplifier will provide 180 degree phase shift or polarity inversion of the input. Cascading of odd number of CE amplifier will provide polarity inversion or 180 degree phase shift. Cascading of even number of CE amplifier will provide 360 degree phase shift or same as input. Question number 43. Which of the following is the fastest switching device? Answer is option C, MOSFET. MOSFET is the fastest switching device because of its quickest response. Question number 44. A field effect transistor can operate in answer option A, depletion mode only. In enhancement mode, the channel does not exist initially and is induced later. That is, the channel is developed by applying and voltage greater than threshold voltage at the gate terminals. On the other hand, in depletion mode, the channel is permanently fabricated by doping at the time of construction of FET itself. A JFET has a channel already created that can allow for the conduction of carriers between terminals designated as the source and drain when suitable bias is applied between them. Unlike a MOSFET, no oxide layer is present, which can create an electric field and induce a channel by drawing out carriers from the substrate material. The main difference between a JFET and a MOSFET is the absence of the oxide layer, which creates an electric field depending on the gate voltage and thus draws out carriers from the material, making them accumulate to construct the channel. Since no such accumulation is possible as per the general construction of a JFET, an enhancement mode of operation is not possible in a JFET. Question number 45. The form factor in reference to alternating current waveform represents the ratio of, answer is option C, the RMS value to the average value. Form factor is defined as the ratio of RMS value to the average value of an alternating quantity. That is, form factor equal to RMS value divided by average value. Crest or peak factor is defined as the ratio of maximum value to the RMS value of an alternating quantity. Crest factor equal to maximum value divided by RMS value. The form factor and crest factor of different waveform is: for sine wave, RMS value is 0.707. Crest factor is root 2 or 1.414. Form factor equal to 1.11. For triangular and sawtooth wave, RMS value is 0.577. Crest factor is root 3, that is 1.732, and form factor is 1.154. For square wave, RMS value is 1. Crest factor and form factor also 1. By heart these values. Question number 46. An amplifier should have Answer option D, all of the above. High fidelity, low noise and stable operation. What is fidelity? High fidelity means sound reproduction over the full range of audible frequencies, that is 20 Hz to 20 kHz with very little distortion of the original signal. Audiophiles amplifiers or high fidelity amplifier is an amplifier that reproduces music that sounds identical to the sound on the recorded source. What is noise? Noise is an undesirable product of the electronic devices and components, and more noise results from intentional economies of manufacture and design time. The measure of the noise performance of a circuit is noise figure or noise factor. Noise figure is the comparison between output signal to noise ratio and the thermal noise of the input. Stability. Stability plays an important role in all amplifiers with feedback. Multiple amplifying stage will have a problem in maintaining stability. The degree of an amplifier's stability can be measured by a stability factor. Question number 47. A pulse transformer uses. Answer is option C, iron core. Answer is option C, iron core. A transformer that is enhanced to produce electrical pulses with a high velocity as well as stable amplitudes is known as a pulse transformer. A pulse transformer is basically a 1:1 transformer which is primarily used in gate terminal firing circuits in power electronic devices such as SCR. It is used to isolate the low power gate firing circuit from the high power circuit for which SCR is being used. It is often called a gate transformer or gate-driven transformer. The function of a transformer is to electrically isolate and magnetically couple two circuits through separate coils of wire, usually on a common iron wire. Solid iron core serves an excellent pathway to provide magnetic flux and retain high magnetic fields without saturating the iron. Question number 48. Barkhausen criterion for oscillator stability is, answer is option C, A beta equal to 1. The output of oscillator will not depend input voltage because there is no input voltage for an oscillator. An oscillator is an amplified circuit with a positive feedback in which a part of the output is fed back to the input via feedback circuit. It should satisfy Barkhausen criteria, that is mod of A beta equal to 1, where A is the amplifier gain and beta is the feedback gain. Barkhausen criterion or conditions for oscillation. The circuit will oscillate when two conditions called Barkhausen criteria are met. These two conditions are: the loop gain must be unity or greater. The feedback signal feeding back at the input must be phase shifted by 360 degree, which is the same as 0 degree. In most of the phase shifter circuit, an additional 180 degree phase shift is provided by the feedback network. Question number 49. What suits best for a Hartley oscillator circuit? Answer is option D, a tapped inductor for inductive feedback. In a Hartley oscillator, the positive output feedback is inductively coupled by a tank circuit consisting inductor coil with a center tap. The tank circuit of Hartley oscillator is shown here. In the feedback, the inductor is divided and separated with a coil at the center tap. The applications of Hartley oscillator is used to produce a sine wave with the desired frequency, mainly used for radio receivers, suitable for oscillations in RF range up to 30 MHz. Some extra points about the oscillator. That is type of oscillator and approximate frequency range. For crystal oscillator, the approximate frequency range is fixed frequency. For Tickler feedback oscillator, approximate frequency range is nearly fixed frequency. For Wien bridge oscillator, approximate frequency range is 1 Hz to 1 MHz. For phase shift oscillator, the approximate frequency range is 1 Hz to 10 MHz. For a Hartley oscillator, the approximate frequency range is 10 kHz to 100 MHz. Colpitz's oscillator, the approximate frequency range is 10 kHz to 100 MHz. Question number 50. For an amplifier, the coupling method which gives the highest gain is, answer is option A, transformer coupling. The basic purpose of a coupling device are to transfer the AC from the output of one stage to the input of the next stage, to block the DC to pass from the output of one stage to the input of the next stage, which means to isolate the DC condition. Transformer coupling. The coupling method that uses a transformer as the coupling element is called transformer coupling. There is no capacitor used in this method because the transformer itself conveys the AC component directly to the base of the second stage. The secondary winding of the transformer provides a base return path and hence there is no need for base resistance. This coupling is popular for its efficiency and its impedance matching, and it has the highest gain among all the coupling method. Hence it is mostly used. Question number 51. How many flip-flop circuits are needed to divide by 16? Answer is option B, 4. For a counter with n flip-flops, the total number of states is 2 raised to n, that is 0 to 2 raised to n minus 1. The largest number that can be stored in the counter is 2 raised to n minus 1. To construct a counter with any mode number, the minimum number of flip-flops required must satisfy modulus less than or equal to 2 raised to n, where n is the number of flip-flops and is the minimum value satisfying the above condition. A modern counter is also called a divide by n counter. The input frequency is divided by the number of states of the counter. Here, number of flip-flops required to construct mode 16 counter must satisfy 2 raised to n greater than or equal to 16. Therefore, minimum value of n satisfying the above is n equal to 4 bits. Question number 52. In 8085 microprocessor, initially the number decimal 8 is stored. If instruction RAL is executed twice on this number, the final number stored will be, answer is option C, decimal 32. We know that accumulator is a register for short-term intermediate storage of arithmetic and logic data in a computer CPU. Also, RAL instruction, it stands for rotate accumulator left. It is an implicit addressing mode having an opcode size of 1 byte. The figure shows RAL instruction sequence. Even if our accumulator is 8-bit, the RAL instruction is going to follow 9-bit rotation as it will include a carry also. Here given 8, that is 00010000, that is 8-bit. After first RAL operation, we get the answer is 00010000. After the second RAL operation, 1 bit is rotate to the left, that is 00100000. Therefore, the corresponding decimal value is 32. And note is that if carry flag is not given, then it is assumed to be 0 while the rotation. Question number 53. In a display specified as 600 into 400, the number of pixels across the display screen is, answer is option C, 24,000. We know that when a digital image is displayed on the computer screen, its size is determined by 3 factors: screen's resolution settings, the screen size, the number of pixels in the image. A monitor may be specified as being a low resolution, which means 640 into 480, a medium resolution of 800 into 600, or a high resolution of 1024 into 768 or more. Note, the first number in the pair is the number of pixels across the screen, that is here 600. And the second number, which is 400, is the number of rows of pixels down the screen. Therefore, the total number of pixels in a display screen is the multiplication of the two numbers. The given display is specified as 600 into 400. Therefore, the total number of pixels across the display is n equal to 600 into 400. We get 24,000. Sorry, 10 is missing in the option, which we will get 240000. Question number 54. If across an ideal resistor, the voltage drop is 24 volt and the current passing through it is 6, then the resistance value in ohm is, this is simple Ohm's law application. Answer is option B, 4. The total voltage across the resistor is given by Ohm's law, V equal to I into R. I is the current flowing across the resistor and R is the resistance. Substituting this in the Ohm's law, we get R equal to V by I. Substituting the values of V and I, we get the answer R equal to 4 ohm. Question number 55. Which of the following IC logic family has the highest fan out? Answer is option B, CMOS. While choosing a particular digital IC for an application, its specification or characteristics should be taken into account. The main specification of logic families are fan in, fan out, power dissipation, noise margin, propagation delay, noise immunity. What is fan in? The number of input that can be connected to a logic gate is fan in. Fan out. The number of units that can be connected to the output of a logic gate. CMOS has the highest fan out among the given logic families. Comparison of the given TTL, ECL and CMOS logic families. Fan in. For TTL it is 12 to 14. For ECL and CMOS it is greater than 10. For fan out TTL it is 10, ECL it is 25 and for CMOS the fan out is 50. That is out of TTL, ECL and CMOS has the highest fan out. Power dissipation in milliwatt. For TTL it is 10, ECL it is 175, CMOS it is 0.001. Noise margin. For TTL it is 0.5 volt. For ECL it is 0.16 volt which is lowest. For CMOS it is 1.5 volt highest. Propagation delay in nanosecond. For TTL it is 10, ECL it is less than 3 that is lowest. For CMOS it is 50 which is highest. Noise immunity. For TTL very good, ECL good, CMOS excellent. By heart these parameters. At least the highest and lowest logic families. Question number 56. When transistors are used in digital circuit, they usually operate in the option C, saturation and cutoff region. Digital circuit works on two levels. One represented by logic high, 0 represented by logic low. These high and low logics are obtained by switching the transistors on and off. When a transistor works as a switch, it works in cutoff and saturation regions. In the cutoff state, both the emitter-based junction and collector-based junctions are reverse biased. But in saturation state, both the emitter-based junction and collector-based junctions are forward biased. That is, in saturation region, transistor is on and in cutoff region, transistor is off. Question number 57. In microprocessors, the IC, instruction cycle, FC, fetch cycle and EC, execution cycle are related as. The steps required by the CPU to fetch and execute an instruction is called instruction cycle. It consists of fetch and execute cycle. Instruction cycle equal to fetch cycle plus execution cycle. The time required by the microprocessor to complete the operation of accessing memory or I/O device is called a machine cycle. Clock time is a non-time state. It is the reciprocal of clock frequency. Instruction cycle is greater than machine cycle is greater than clock cycle. Steps in the instruction cycle. First of all, the opcode is fetched by the microprocessor from a stored memory location. Then it is decoded by the microprocessor to find out which operation it needs to perform. If an instruction contains data or operand address which is still in the memory, the CPU has to perform read operation to get the desired data. After receiving the data, it performs to execute the operation. Correct sequence is first fetch, second one decode, then read effective address, then execute. Question number 58. A 256 into 4 EEPROM has, answer is option B, 8 address lines and 4 data lines. The total memory can be calculated from the number of address lines and data lines. That is, total memory equal to 2 raised to address lines into data lines. From here we can understand that 2 raised to address line is 256 and data line is 4. 2 raised to address line equal to 256. That is, for a 256 into 4 EEPROM, the number of address line equal to log 2 of 256, which is equal to log 2 of 2 raised to 8, which is equal to 8. That is 8 address line, and the number of data lines is 4. The Boolean expression AB bar is equivalent to, answer option B, A bar plus B bar by De Morgan's law. The De Morgan's law states that the complement of product of all the terms is equivalent to the sum of the complement of each term. The complement of the sum of all the term is equivalent to the product of the complement of each term. The last question of this video and this section is 60th one. The resolution of a dual slope ADC can be increased by, answer is option C, increasing the clock frequency. The resolution of the dual slope ADC is determined by the length of the rundown period and by the time measurement resolution, that is frequency of the controller's clock. The resolution in the number of bits is the minimum length of the rundown period for a full scale input, that is Vin equal to minus Vref. TD equal to 2 raised to R divided by F clock, where TD is the rundown period and R is the resolution and F clock is the frequency of clock. Note: there are limits to the maximum resolution of a dual slope integrating ADC. It is not possible to increase the resolution of the basic dual slope ADC to arbitrarily high values by using longer measurement times for faster clocks. Thank you. Thank you for watching this video.